Hello, it's Pauly G back with another math question. So, Ginny, this is a really great question. I knew you asked it a day ago, but hopefully you're still looking for an answer. So it says use logarithmic differentiation to calculate the derivative of this function here. So what we have is y. Let's get started here. What we have is y equals 1 plus x to the power of sine of 2x. Now the problem here is that the sine of 2x is in the exponent's position, right? You would be wrong to just do the power rule here. We need to get the sine of 2x out of there. And this employs one of my most favorite rules in math, and that's what I call the throwdown rule, where if I have the ln of a to the b power, well, you can throw down the b and make it a coefficient. So if I apply the natural log to both sides, what you do to one side, you must do to the other. You can actually make the sine of 2x a coefficient instead of an exponent. And that would resolve our problem, our annoying problem of having it there in the exponent's position. So we're literally going to throw it down here. So sine of 2x times the ln of 1 plus x. Now at this point we can differentiate both sides. The sine of the derivative of ln is 1 over y here. Don't forget the chain rule, dy dx. This employs implicit differentiation as well. And then we're going to have to do the product rule here. The derivative of f times g is the derivative of the first times the second plus the derivative of the second times the first. Right? So the derivative of sine of 2x is cosine of 2x. Don't forget the chain rule, times 2. So the derivative of the first times the second. Okay. And then plus the derivative of the second. The derivative of ln is 1 over whatever it is on the inside. The derivative of the inside, 1 plus x, is 1. So that would just be times 1, but we don't have to write that. Times the first. So that leaves it unchanged. Now at this point, all we want is dy dx. So what you should do here is isolate dy dx. And remember, you know what y is. They gave you an expression for y, so don't leave that in there. You'll have an expression at the end that equals dy dx equals all of that. And then you'll have to, you're basically at the end at this point. So very good, really interesting question. I really enjoyed it. Hopefully this is helpful.